going to get started. This is the panel discussion on video compression and applications, advanced video compression, not just ordinary. Excuse me. We should have a lot of fun. We've been doing this for about 8-10 years actually already, and it's been my pleasure to host these panel discussions. A couple of the regulars that we have had all the time couldn't make it this year. Gary Sullivan in particular, for good reasons, but also a couple others, Benjamin Bros and Al Bavik couldn't make it this time. But we still have an outstanding panel. Very pleased to have them, and we'll meet them in just a second. But let's introduce our subject. Since about 200 years now, fossil fuels have been sort of the economic drivers in our industrial world. But in the last 20 years, I would say, with the rise of information technology being more and more prevalent, it's things like network connectivity that's playing an essential role as a new important resource. Now, video happens to make up, by some estimates, and there's some controversy, but video makes up some 80% of IP traffic on the internet. At least that's what Cisco predicted several years ago. Among those videos, then 80% of those videos are in fact run by a single codec, H.264, which was invented in 2003. Since then, we've had an enormous slew of video codecs, and we'll go through them in some detail here. But the issue is, how good are these codecs, and when will we see the applications of those? So we're going to discuss them with this high-powered group, and let's meet who they are. I'll start by introducing myself. I'm Pankaj Topiwala of Fast VDO, a small research firm focused on video compression. And go ahead down the line. Go ahead, Fabian.
I'm Fabian Cafe.
Please.
I work at Intel Digital in the US and working also on video compression.
Very good, very good. Go ahead.
Yeah, hi, I'm Yuri Resnik. I'm VP of Research at Breitkopf. I've been doing compression since about 1989, video coding since 95. So
Wow.
Yeah, not I don't have the history, unfortunately. But my name is Simone Ferrara, and I'm working at Minova, and I've been kind of leading the work in BEG relating to one of these codec, which is LCDC, which I'm sure that we will touch upon.
Okay, my name is Matthias Wien. I'm with Aachen University, RWTH Aachen. That's the name of the university, and I'm into video coding since the late 90s, maybe. I think I attended from 99 on. And I'm currently the convener of the BIG Visual Quality Assessment Group.
And I'm Michael Horowitz. I work to integrate new and improve existing codecs in Google's real-time communication optics.
Like Meet and
Duo.
And Duo. Pretty cool. Well, that's a pretty powerful group that we've got over here. Let's see if we can ask them some good, tough questions to get this thing kicking then. I mentioned that there are a lot of codecs beyond 264, but in fact, there are codecs even before 264 that are still in use. MPEG 2, for example. So we have not only MPEG 2, but BP6, 8, 9. BP10 turned into 81. We have various others like BBC and, of course, HEVC. There are still further ones in development, like ECM version of BBC, and AB2 is in development as well, being called ABM right now. So that's an awful lot of codecs. Now, which ones of these are really going to, given that we estimate that 80% of video streams right now are still 264, and by the way, 264 has one more trick up its sleeve. It's 19 years old today. Next year it'll be 20 years, which means it'll become free. When 264 becomes free, what will hold back any users from keeping it going another 5-6 years? So let's get an opinion from everybody here as to what codecs are really going to be used, let's say in the next 3 to 5 years. Let's get an opinion. Go ahead, Fabian. if you got any idea. By the way, I want to make one thing absolutely clear. Even though we mentioned their affiliations of these panelists, they're not here to speak on behalf of their companies. They are experts in the field of video compression and speaking generally and for themselves only. So that, there's no burden on them to be able to represent the company line in any way. Yeah, so feel free to just speak for yourselves. You're empowered to represent yourself. So go ahead, Javier. You're not speaking for an individual.
I'm the only one who did not mention it, but I started in 2008.
So you're the youngest person in our group.
And at the time, some experts were saying, like, we don't need HD, H.264 is not going to make it, MPEG 2 can do pretty well. And,
So there's been resistance all the way along.
So I would not, I would say that VVC is state-of-the-art, and I'm a strong supporter.
You're a good supporter of it. Very good, very good. So in other words,
people might
onward and forward,
some
right?
people might even skip HEVC and go to VVC.
So I have heard talk about that. In fact, in the cable industry, they've been talking about skipping one step and going to a next generation, codec. Do you think that'll really happen? Have we ever seen that happen? So let's, maybe go on to, go ahead, Yuri.
Well, we certainly have seen it happen.
Speak up, by the way. You gotta be heard on the camera.
We certainly have seen this happen. MPEG 4 Part 2 visual, for example, was created with big hopes in MPEG, and it got not exactly in any kind of massive deployment outside of a few short-living exercises. So we still produce some streams on MPEG 2, MPEG 4 Part 2, but it's like a fraction of a percent.
So you mentioned in proper discussion earlier some numbers coming out of your lab. Let's hear some of those numbers as to what codecs are actually in use, say at Brightcove.
Well, I'm not sure if I could say everything and exactly, but let me just,
roughly.
let me give you some ballparks. So out of videos we transcode a number of videos. So hundreds of millions is a right number to put on a yearly scale, and certainly many more in our catalogs that are just stored for delivery. And out of what we see being transcoded, vast majority is H.264.
Beyond even 80% level.
It is beyond 90% level. And
so that's really stunning. 19 years on, H.264 has a stranglehold on streams being put out. Whenever I watch video on anything, and by the way, if you're YouTube, if you're doing Zoom or Google Meet, well, I don't know about Google Meet, but if you're doing Zoom, you're talking on H.264. There's no question about that.
Not meat.
Not meat.
Not
go
meat.
Yeah. So go ahead. And what other codecs besides 264 are out there?
Well, HEVC is obviously kind of picking up, and we're happy to see the trajectory, but it's so distant second that this is not even like comparable. But then, of course, there are legacy codecs, VP8, VP9, VP6, remarkably enough, VC1.
VC1, I remember that? You remember that codec?
Remarkably enough, if you send videos to Xbox and one of those versions and you want it to be DRM protected, and there are a few extra nuances that comes into it, and using smooth streaming with VC1 is the only way to make it happen.
Unbelievable. By the way, the DVD standard had to adopt 3 codecs. It's unbelievable. 3 codecs were standardized in DVD, as I remember. It was MPEG 2, 264, and VC1. All 3 had to be in the box, which is wow. 3 codecs. Okay, go ahead.
But there's one correction though. You mentioned that H.264 was 2003. 2003 is when the standard was published, but when Gislav Yandegard brought first proposal in VCAG, before it was called VCAG, it was question 15 of study group 16. It was 1998.
Yeah, it was a long time in development. What you're trying to really tell me is that many of the patents have already expired. And that's likely true. But we're talking about all patents effectively expiring, next year. That's an event.
By the way, the way Gisela presented that proposal was also brilliant. He said that this is a minimalistic codec in which I throw away all the babies that I invented over the last 10 years before. So it was by itself stripped down variety. It was just on pages.
We're just remembering a great a person in the field of video compression, Gisela Bjørntegard, made a lot of great contributions, and so we're paying some homage to him. Let's go ahead with Simon. Let's get your point of view. Go ahead.
Yeah, I think from my perspective, I think it really depends on kind of the areas where we're looking at, and I think we're getting more polarized, although there are attempts to bringing them together, but very much broadcast and kind of OTT delivery are two very different drivers. So I think on the broadcast side, it's really down to kind of two factors if you want. One is regulation. So typically you need to have some kind of standardized body that kind of, if you want to impose, and we'll use this word, maybe it's a bit too much, but would say this one is the codec to use for this specific whatever.
But each market is different, so
and each market is
Germany
different.
versus Brazil versus, yeah.
Exactly. If you look, for example, at the three codec, the most recent one, so HEVC, very recent to a certain extent, but HEVC currently, I believe, is specified in DBB, not adopted in all countries because that's not how DBB works. ATCC has it, ATCC 3.2. That's it as far, I think, the biggest, if you want, broadcast association. BBC, specified in DBB, again, but obviously deployment will take some time. At TV 3.0, which is the Brazilian new standard, LCBC, which is the latest one, again, also in TV 3.0. So it really depends on I think, on kind of what body pushes this codec, and ultimately replacement cycle will take also that into account. I think on the OTT, if you want, side is a bit more Wild West to a certain extent, because there is no really regulatory body that says you need to use this.
It's the highway or the highway in that world, and some big parties can push their way.
And I think H.264 has the big advantage of being still the minimum common denominator on devices. And I think that is not going to change much, I think. So if you want really to serve the vast majority of your population, which may have devices that are probably 20 years old is too much, but even 10 years old, you still need to focus on H.264 and then starting to introduce new codec, and obviously with OTT and the fact that you can deliver ladder, as Yuri was presenting yesterday, mixed ladder nowadays, then obviously you can start introducing that for different profiles. So I think on the OTT there is probably more ability to kind of introduce new things without the push for, but you're still bound by mobile power, and the complexity argument is still a relevant one because a lot of these mobile devices don't have much battery. So they're getting better, but if you then start thinking about AI and all this stuff.
So we'll get to that in a little bit. Go ahead, Matthias, let's get your point of view. So Matthias works, of course, in standards development for the last 20 plus years, so let's get that point of view.
Oh, okay. So actually, I didn't want to start from the standardization perspective, but more from the maybe from the markets. Maybe it's something like a saturation thingy or so. So we always have to regard that the tool chains that were built up are out there, right? And then so it's a huge invest, and everybody understands that tool chain, and it's used, and people are trained on it, and they know how to act on that. Now, if you come with a new tool or a new codec, people would need to change it. That's a huge investment, and I think maybe it's actually comparable to something like maybe railways, right? So you would never change a railway system like the width of your tracks or something like that because of the effort it takes. I mean, to some way, I think it's comparable. So once you have set up the system and that way it's running and it's sufficient, I mean, it was designed to be sufficient for the application, then it's very, very difficult to replace. So if you have a new field of application, like, I mean, if you have a new, let's say, new resolutions, maybe the HDR thing could be something like that, where you are forced to use the new thing, and then of course it makes sense. And I think it would also make sense in the other domains, but it's very difficult to switch because the whole process is running in the other directions. And I think that makes it difficult to be picked up, right? And the fragmentation doesn't help at all, of course, because there's so much to be supported. And but this is actually the world of competition that we have, right? And there's nobody preventing to get more codecs, right? Because the cake looks like a big cake, so everybody wants to have a piece. Right?
In fact, that reminds me of a comment that Yuri made a few sessions back, that you know, last thing we need is another codec.
Well, it would come for sure.
But he's helping to make more. Go ahead, Michael.
So in the RTC, and when I say RTC, I mean real-time communications. I'll probably use those terms. I prefer to use, I just use RTC more often than not.
Get so closer to your microphone.
Is it really?
Yeah. No, I just want to make sure that.
Okay, I can hear myself. My apologies. So for Meet and Duo, and that's the context that I'm talking from, until about a year ago, VP8, and this is really H.264 generation type technology from the late 90s, was ubiquitous in the ecosystems that I'm talking about, Meet and Duo. And starting a few years ago, we integrated VP9, and to your point, it's, even though we can negotiate things on the fly, integrating a new codec into our ecosystem, which is arguably much easier than into many of these other ecosystems, is tremendously complex. It's just so much has to be done to ensure the quality of experience that the older codecs that we've enhanced over the years, and you just have to bring all those enhancements plus into the new codec. So there's a lot of work. At the beginning of this year, I think a relatively small percentage, less than 25% of all meet calls were VP9. And we made a concerted effort to identify what the roadblocks were.
So just this year, you're saying?
Yeah.
This year, 2022?
January.
So before that, 75% were VP8?
Oh, and before that, 90%.
Wow.
Yeah. Oh, and by the way, 264, at least in the last 3 or 4 years, almost nothing. So
Wow.
at least that's
In Meet.
we're moving forward on that side. So we made a concerted effort to identify the roadblocks for adoption. And today, for enterprise, 91%, 92% is VP9.
So in less than a year, you migrated from 25% to 91% VP9.
in the enterprise overall, it's like 60%.
Wow.
Consumers are a little bit harder to they don't update as much, as fast. They don't have as strong functions.
Yeah. Okay, but that's pretty impressive. You know, can you do that to my bank account too? Or okay.
Well, and remember, for the previous years, your bank account would be doing that.
That's true. Yeah, right.
Yeah, right. It just you can't do the market timing.
Okay, you can't do that kind of thing all the time. Just once in a while when there's an opportunity. Okay, well, you know, speaking of opportunity, you know, let's mention what this pandemic has done. You know, to not only to all of us, but done to this field. The 2020 pandemic not only put basically the entire world on the stop, but highlighted the opportunity for communications by video in a way that nobody predicted. And in fact, live video communication became central not only to technologists, but to every industry in the world, because they had to talk to their employees, and this was the best way to do so effectively with all the nuances of human communication. And so, in fact, video conferencing became the top application, you know, in 2022 that made all of industry possible. So one thing that this group has done has created a technology that could be used around the world, and that, you know, that's just going to continue to improve. So one thing we can predict immediately is that from all the research in video compression that's been going on, new technologies and new applications will emerge, and the old applications will just get better and better. Well, let's discuss some of that. What new, so with compression technology now being 3 to 1 better than 264, some cases even 4 to 1 better than 264, what fancy new applications will arise? For example, is 8K HDR going to be the next killer thing? 4K HDR already is getting to be pretty well penetrated. It's clear that in the next 5 years, it will become the dominant technology, I would guess, in the marketplace. But is 8K going to be, the next thing? And is 8K the end of the line? So for example, if you want to do VR, 8K might not even be enough. You got to get really high resolution, 16K maybe, in order to make it look real to you. And until it looks real, people aren't going to buy it in droves. So let's talk about AR, VR. Let's talk about, but there are two ends, higher compression can enable things at the high end. They can also enable things at the low end. Things that you could do at low bit rates. For example, in audio compression, first we had 64 kilobit, total quality audio for voice communications. As we got better and better audio compression, we could able to do voice communications at 4 kilobits. I mean, that's where that technology, and then past that, nobody cared anymore because bandwidths are so good. We don't, maybe, okay, so, Michael's going to tell us that maybe in that space, that's also important too. But okay, let's talk about both the high end and low end. What new applications are going to emerge? Is AR, VR finally, so for example, the company Meta changed its name from Facebook to Meta. It's building itself as a metaverse company. Is that going to really take off in the next 2 to 3 years? Let's hear what you're, and we're just taking, pot shot guesses. None of us knows the future. That's why it's so much fun. Go ahead, Fabian. Any idea? Any new applications?
For the VR, I think it's more a matter of can you have your headset for more than 30 minutes?
Well, that's a problem in itself. No matter how good the compelling video is or the content is in VR, can you tolerate having your eyes closed in a box for a very long time? And that's, it's got to be really exciting for me to keep it on more than 5 minutes.
Even glasses for 3D or it failed, right?
They failed, yeah. People didn't want to put on something. So you predict that VR is going to be a hard sell no matter what resolution.
But I think even without talking about VR, just the gaming industry, like
Yes.
live streams of
Yes,
games,
yes.
has like both constraint of control of latency
Yes.
and low bandwidth,
Yes.
which is kind of demanding on the.
So in fact, you think that application may benefit the most?
The gaming industry tries a lot of things.
Well, it's amazing. The gaming industry, by the way, let's talk about that, has grown to be a mammoth size and at one point passed the revenue streams of cinema, live cinema. And that happened a number of years ago. It's now well beyond that. What is it, like a $50 billion industry? It's a huge industry. And, it's an important part of the technology world. Big companies like Microsoft and Sony and others invested heavily in that space, and they really played a big role. Go ahead, Yuri, any bright new applications you think?
Well, let me kind of sort different things that you brought previously.
Quite a lot. A lot on the plate.
When we're talking about gaming and streaming gaming, it's still videos, arguably with low delay, but it is still in the domain of most of them today mentioned videos. When we talk about future video and kind of beyond, 8K, 16K by themselves, if this is a 2D display, I think it's nonsense, honestly speaking.
So you think even 8K is not really, there isn't a compelling argument for 8K?
There is no compelling argument by itself, unless you're talking about some very specialized setting. You create a room with controlled lighting and special content or your acuity artificially boosted and so on. So, but and you really have very wide viewing angle, and that's what you're trying to achieve with the application. What I think would much more drive changes, progress in display devices, light field devices, how compelling those might be.
Okay, so you think newfangled things like light fields will finally enter the consumer market?
Light field are approximations of light field. As you know, they all not exactly light field, they all effectively hugely supersized matrices with optical layer on the top. But that seems interesting, and let's see what the future brings with the evolution of those displays. And when we're talking about headsets, I would argue that bandwidth is not important at that point. When you're talking about VR headsets, what is important is accurate eye tracking and low delay of connecting to the transmitter, because at that point you could just do foveated video, and I'm sorry, 2 megabits is good enough to have perceptual rendering, perceptually transparent rendering. And just based on capacity of optical nerve connecting retina to operants. Just physics here. But that's my thinking of, you know.
So Al Babic would disagree with you. He's been a lot of work on that space, and he'll tell you that in fact you need better than 8K resolution per eye in order to get a quality that the human viewer would consider realistic. And then now, of course, you're absolutely right about low latency. When I turn my head,
is he talking about stabilized retinal image resolution or resolution with arbitrary eye movements and reaction? With arbitrary eye movements, yes, you need more pixels.
Right. So we have to allow the user to move their head, you know, anywhere they want. In fact, the point is, in reality, you turn your head, there's no latency. It has to feel like that. You have to have an experience that looks real to you. And when you get that, it may be a killer app, but we're not anywhere near that. And the problem is that we don't have chipsets that can decode, you know, transmit and decode that fast, you know, right now, and with no codec. Never mind.
5G claims 5 millisecond.
5G claims 1 millisecond, and it's all nonsense. We haven't got anything like that I've seen. I play on my phone, my 5G phone all the time, and I don't get anything. So I typically see 30 milliseconds, you know, and that's the best I get. I don't get better than that. Are you seeing much better latencies than that?
Well, if you're connecting to server on the other planet, side of the planet, of course, I'm talking about with a direct connection to base station. It's like 3 levels or 4 or 5 of hoops of network connections we are talking about. And to deliver low latency sufficient to rendering of stabilized retinal image, you just need to have last link fixed. Assuming that you could put it, you know,
right.
a
So there's a transmitter right there.
That does the rendering right there.
Right. So I think that might just do it. So that, you know, so in other words, you're saying with 5G, real-time VR that's credible with low latency will finally become possible.
I think it's.
So in the next 5 years, that's coming in the next 5 years.
Not 5 years, but it is coming in the domain of something that might emerge actually in the next decade or so.
Interesting. Go ahead, Simon, any ideas as to
Yeah, well, actually, picking on that, I think also based on experience, you know, we're working on this quite a lot, but I think it's the paradigm really, because we've been talking about the device doing the stuff, but in particular on the VR, XR, if you want, and on the metaverse, is really not something that is going to be done on the device, but it's something that is going to be done as pre-rendered, potentially in a place that is quite far from the device. So the ability to transmit, receive, pre-process, pre-render, and then, you know, in real time to display on, you know, on a device that are quite powerful, but not as powerful as being capable of necessarily rendering very complex and very computationally intensive video, which are also responsive to what you're doing, because it's not just a passive video that's been encoded in a movie. We're talking about things where, you know, you can have placement, advert placement based on, you know, where you are in that moment. So the ability of doing that, I think, will require some. I mean, it's if you want, it's an ecosystem. So it's not just about the transmission. By the way, just as an anecdote, I still haven't managed since Sunday to get beyond Edge in San Diego. So I'm not sure the 5G, but I definitely Edge is yeah. I think I hope still to get 3G at some point.
It's a real issue. Absolutely.
So I think in terms of application, you know, I can say what we're working currently. I mean, the Cloud XR is a very exciting thing, and on the metaverse, it's quite critical to get that ability.
Yeah, but how are you going to transmit from that cloud to the viewer in a way that feels interactive to you? That's, you know, what Yuri was saying, that transmitter has to be right in front of you, and now 5G is fast enough to give you the latency, low latency that you need. from the cloud, it seems to me, even with 5G, that doesn't seem doable, but you know,
No,
I'd
it's
love
not,
to see.
as I said, it's not a combination just of the delivery technology.
Yeah.
It's also a combination of the kind of the system, but also the codec. I think the codec will play a role in that. And the ability of a codec, not just to look, and in fact, I have actually, a question whether, we're talking about compression,
Yes.
but is compression about compression? In the sense that, it's only about putting bits down, or we need to think about formats that enable to potentially, scale up, scale down.
Let's talk about that in a minute. I'm going to get to scalability in a second. Go ahead, Matthias, see if you have any ideas as to what applications will really hit the road in the next few years.
Well, since I'm from the university, I'm allowed to be a bit fuzzy on that topic.
Absolutely, absolutely. Look ahead. Get your crystal ball out. Go ahead.
I wanted to bring up another point with this resolution discussion that we had, right? So
Okay.
you were asking about this 8K or maybe
And
16K
beyond, right.
and whatever.
Right.
And I think, if you have this 360 scenario and you have your somewhat resolution, and then you look into one direction, then you see something like 12% of the resolution. That's why you need these very high numbers, right? So that's given, that's fine. But I think there's a much more important aspect to it, which currently might make it fail, which is the fact that you can't move your head. So you have this pinpoint position that you're stuck to, and no matter what resolution you have, right? If it should be immersive, you have the impulse to at least move your head. And once you do that, the thing is broken. So you need something like this. And there are standards coming, like MPEG immersive video, that tries to do that so that you have some kind of, let's say, 3 degrees of freedom plus, so that you not only look around on the pinhole, so you don't have to fix your head, but you're allowed to move a little bit around. And that's something that may be feasible.
Yeah,
Right?
so 3.5 plus.
Otherwise, and you need that in stereo, so you need 2 views for each eye, you need a separate view, you need to be able to move around a little bit at least, so that you could say, so if I'm sitting on my chair and I kind of shake my head a bit, then I still have the right impression.
Right.
And if that doesn't work, people will not take it.
Nobody sits still. Nobody sits still in this, in the
absolutely.
real world.
And then at the same time, people are used to that because they play maybe, so people who would put on this thingy and, be decoupled from their environment, and so they are trusting that nobody would fool them while they're behind the glasses or whatever. So, if they're playing computer games, they have that, right? So in the computer game, you move around, you're totally immersive. Maybe it's even fast enough so that it's really kind of worthy. And so when they see that as a video, they want to have the same, and they don't get it. And I think this is really a challenge for the community to basically build something that's capable of doing this. And we have seen, this free viewpoint TV stuff that was going on, maybe even in the late 90s already, or like in the beginning of the 2000s, and then you had these displays which would have multiple views, and then you had these standards that were developed like multi-view HEVC or 3D HEVC, and while those standards were developed, the whole technology vanished. For a while everybody was talking about it, but people were not picking it up because the end part of it did not work well enough. And so, you have to have a certain market drive on it, but if there's a technology flaw on the way, you might never be able to pick it up.
So if I could summarize what you're saying there's still quite a few roadblocks along the way to making VR.
It's not a roadblock, I think it's a good challenge. It makes people being able to work in the field, right? So that's
Good job security for you. But in terms of wide deployment, I'm talking about roadblocks towards wide deployment. There's still obstacles to overcome. And one of them that you mentioned is you cannot just have 360 video. That's not enough. You have to have 3.5 plus or 6.5 minus to be able to feel realism. Good. I like that. Now, Michael may tell us about not the high end where we use all the bandwidth we have, but at the lower end where we don't use all the bandwidth we have here, but we allow users around the world to have capabilities they don't have today. Go ahead, Michael.
That's right. So I'm going to come at the other end of the spectrum. The pandemic, as you mentioned, made a huge number of people aware and actually savvy at using RTC communications, where either hadn't used it or hadn't gotten good at it. As an example, we saw a 50 to 60x, not percent, 50 times or 60 times uptick in the first few months of the pandemic, and largely it's stayed. You were going to say?
So I'm just going to say, you know, I have never heard of a thing like that where a certain technology within a matter of months multiplies 50x, you know, in terms of its use. Wow.
There were a lot of long nights.
Too bad you didn't make any money on that.
Yeah, too bad.
Yeah. Bad business model.
But in any case, so all of a sudden, people are using video communications. And I'm interested in places in particular where, for instance, let's look at 100 kilobits per second on mobile networks. And you think, come on, you're on the edge. So in the United States, at least the data that I see, about 10% of calls have less than 100 kilobits per second available for video. This is on mobile communications.
Yeah, this is the United States.
This is the United States.
What's happening in Nigeria?
I don't know Nigeria, but I do know India and Indonesia, it's greater than 25%. And when I say less than, I don't mean 99 kilobits per second, 50 kilobits per second, 30 kilobits per second.
Right.
So to address this, Duo in particular, we released AB1 at the end of 2020 or August 2020. And we tuned it to be able to have a real video conference with acceptable quality. The video bit rate, 15 kilobits per second.
So bit rates that we previously used to compress audio is now being used for video.
And that's why 4 kilobits per second, good for audio.
Yeah.
3 would be better.
Yeah.
Because I'd like to go lower than
We could get 2.5, I believe. I think, you know, latest technology that I understand, 2.5 kilobits for audio is decent quality. I wouldn't say total quality, but decent quality. Go ahead, Yuri, you have something to add.
It just sounds like we're going back in history. You know, real video was operating about same bit rates as kind of the lowest level of entry point, but of course quality was not there. But those were the bit rates. You know, 48 kilobits was a luxury.
Yeah.
Some people had 28.8 if the channel was clean.
But you're talking about the United States have access to those bit rates.
Yeah.
I'm talking about
Now he's talking about the rest of the world.
the rest of the world,
Yeah,
2G, 3G.
Yeah.
But this is a good flashback, and then, you know, it's a reality.
And when I was at Polycom in in the late 90s, early 2000s, we did 264, one of the first, if not the first, 264 in product. First thing I did after the product was released, I did some tests doing QSIF, at a very small resolution, 10 frames per second. And the quality was exciting that you could recognize somebody, but it really wasn't product ready. And now we can get pretty decent, significantly larger, more pixels at 15 frames per second. I want more of them.
Yeah, well,
There's a real video what it was doing in like so-called duress mode. It was switching to intra only, and that was going like to 5 kilobits when you just only project keyframes.
5 kilobits video.
Yes.
Wow.
Once every 10 seconds you have a new picture coming up, and that was the way to operate in extreme.
Well, you know, one thing that points out is the following. You know, you could start a technology at, say, a moderate quality, and it doesn't get picked up. When it gets to be high quality, but not for everybody, even then for a sufficient number of people, it gets picked up. But when that gets picked up, then even the people who don't have the same bandwidth, they want to have that technology. And now what you need to do is provide a solution. So that's what you're answering, the need for people to do video communication now at bandwidths that people never, you know, had a chance before.
And there's other things as well. We need it to be ultra low delay because it's interactive video, and we need it to be, complexity has to be accessible for 5 or 7-year-old entry-level cell phones.
Right.
And generally we need to do it in software if we're at the cutting edge, and if not,
Yeah, they don't have GPUs on those phones, yeah.
and if they did, it would melt your hand. But that's a different point.
Yeah, all right, Matthias, I think you had, and maybe Simone, you had something to say.
I just wanted to bring up the fact that, I mean, we were talking about QSIF, right?
Yeah,
So
QSIF.
that's 176 by 144
Yeah.
pixels,
Yes.
which is about the size of a block in BBC,
Oh, yeah,
right? So it's, what has been the video before now is,
it's just a block.
it's just a small block somewhere in this very huge video,
Yeah.
right? And this makes really a lot of difference in there, right?
It's more than
We're already having a lot of
80 by
controversy
80
here.
pixels that is used for basic face recognition, so it's good enough.
Yeah, well, if you want to see some color moving, by the way.
Well, you know, there are many, many topics we can discuss here, but I want to mention one other thing. Since the days of MPEG 2, we've had scalability. It has never been used. Scalability since MPEG 2 that I know of never got, well, okay. Michael has another exception. One company did use it.
No, all the companies are using, now, what do you mean by scalability?
Okay, hang on.
Simulcast, mostly, but there's SVC.
Okay, so let's get into that in a second. But now we're seeing evidence. So in fact, what I was going to say was that since MPEG 2, there's always a 20% penalty for using scalable versus the single rate. There was a penalty for using a scalable version. There's always been a penalty. That was true with 264. Even with HEVC, we were, maybe 17%. There was a penalty. And Matthias, I remember you did some tests for a scalable version of HEVC. There was still a penalty. It was reduced, but there was still a penalty. Now we're seeing evidence for this first time in this meeting that maybe with BBC and maybe with LCVC, we have technologies that can do a scalable codec and not pay a penalty. Is that really possible? And do we see any strong evidence for it? And is that going to spark new applications? So let's sound like an exciting topic. Let's get some opinions. Go ahead, Yuri. But Fabian, I want to get your view also, since your company presented some of these results.
Well, that's exciting news.
Yeah. So you think it'll get used?
I think one of the big differences is that like SBC and even SHC, they were like thought after.
Yeah, afterthought.
BBC was more like in sync with the.
Right. Well, the main thing is that we wanted to have everything that deployed it to have all the capabilities. That was the idea. Yuri, go ahead. You had something to say.
Well, let's be a little scientific and then step back and see what we see in reality. In science, it's called successive refinement theorem and information theory. And it's known since 70s. There was a famous paper by Tom Kohler and Equitz, and they established that if you encode a source, right, and you encode it in one step, or you do it in a scalable successive steps, then you can only achieve at best the rate distortion of a single step encoding in a very special situations when you have particular source and some other things aligned.
So in general, you can't expect a scalable thing to be as efficient.
It's mathematically impossible to make scalable things to work better than non-scalable, but this is in theory when we're talking about the characteristic of a source and its rate distortion function as a mathematical concept. Now, when we go to practical world and we don't have a model of the source, and all what we're dealing with is empirical or operational rate distortion function achieved by some other codec that is doing something with some data which are not exactly categorized. And you do it 2 times and more. When you do a scalable system, you not only use tools of this original codec, but you arguably add something more sophisticated that was in the original codec, right? Mm-hmm. Of course, maybe you can gamble with your system, but you can gamble it within the space of what is your test status, right? Which model...
So you don't think they can generalize that scalable things can be, even competitive or even better than single rate? It doesn't seem to make sense to you mathematically.
In limit, if we have ideal codecs, if we do solve problem in a mathematically proper way, it's mathematically possible.
But real world doesn't always match what our theory says. But that's always the case. Simone, your company is put up a technology that it's not LCVC is not a codec, but a codec enhancer. But if you start with a base layer, say VVC or HEVC, you can get streams that get you good quality and have the ability to be at better rates than the base layer codec if it were used at full resolution. And now you're not designed to be a scalable codec per se, but you can offer some scalability. Do you see an opportunity for scalability to play a role in the near future to solve problems that can't be solved with single rate?
Well, I think you're correct in the sense that for us scalability is, if you want, is a byproduct of the design of the
Yeah, it wasn't the main design.
scheme.
It wasn't the main goal.
So I mean, the scheme is designed very much with different parameters in mind, and one of them, in fact, there is a presentation later on from one of my colleagues about reducing the complexity. So, we talk always, as I said earlier, about compression in isolation, as if we had all the power available in the world, but in real application, in real time.
Yeah, we're limited to battery power. I mean, these devices, absolutely.
No, but also, I mean, we're talking about RTC. I believe that you have, you need to cope with what the device can decode, and also what you can encode within a certain time frame. So the ability to use effectively, if you want, scalable approaches to kind of reduce that computational power, whilst also then, as a byproduct, also benefiting, and being able to deliver to a large quantity of devices, because you still have a backward compatible, if you want, base there. And I think that's if you want, a value proposition that obviously we've been working on, but it comes from the design, if you want, of how we did it. So.
Matthias and Michael, what new ideas and what new applications you think scalability can offer that single rate codecs can't? And by the way, VVC codecs like VVC and HEVC can do scalability. So it's not like these codecs can't do it. And we had a presentation yesterday saying that VVC scalable VVC seems to be performing really well. Go ahead.
Yeah. So again, I mean, you're asking the university guy for the applications.
That's okay.
But I wanted to bring one point up in terms of the design. So we have the MPEG-2 way of doing scalability. It was quite different from let's say, H.264 ABC, because in ABC, or in SPIE, which was the scalable version then, there was this attempt to say, we have this complexity topic under consideration, so we do a design which does a single coding loop, right? Which is very different from what the others did and what the others do now, right? So SVC was the one. We would have multiple resolutions, you would have multiple quality layers, whatever, but there would be a single motion compensation loop running, and there would only be one deblocking, right? So, and that concept, I think, technically was a good idea in the sense that you would say, okay, you try to reduce the amount of complexity that you have there in terms of computation, but then the description complexity was such that nobody was able to do that besides very few people, right? So, I mean, there was a company that was able to, and there was maybe other people, but only very few.
It wasn't widespread, that's for sure.
Yeah, and it did not, this design benefit, right? So saying, just having a single loop did not help to make it like a broad application, right? So because it simply was not taken. And HEVC scalability is just running the base layer and just run a enhancement layer on top, and you do everything on every layer. And that complexity concern that was really kind of driving the whole activity in SVC was basically gone. And in SVBC now, it's just the same thing. I mean, there was not so much novelty put into a scalable VBC. It was just basically saying, okay, we have the reference picture resampling stuff and these kind of things, that we just used that. And I think, well, what LCEVC, for example, does, it's a bit more clever in that sense, because it's more designed for the purpose, which gives a conceptual potential benefit, I think. Right, but then it's two different systems, right? So I don't know where the conceptual best way would be, right? And it also depends, of course, on what kind of bit rates you have available. If you say you want to, let's say you have one rate point and then you double the rate, and you say you call it scalable, then probably it's not necessarily the point where the operation would just really be beneficial. Right? So that's just technical aspects of the discussion. If you want to talk about scalability, I think it has value, but it's a specific niche where it would just have that value.
Michael, we're going to bring it to you now. You have some experience from prior work of using scalability, and let's hear some of that.
So I don't think we have enough time. I'm going to just
Give us the 2-minute version.
So maybe 3. Let me first tell you about it for real-time communications when you're talking with many people in a conference. Not everyone can receive HD and VGA and or the base layer. So there's a great value in being able for each encoder to encode at all these different resolutions. Before SBC, what everyone did was a transcoding, it was called an MCU, where every endpoint did one resolution. The MCU would decode all those videos. It would then re-encode them.
So that's an awful lot of work along the way.
These MCUs were $250,000 and $2,000 and added 400 milliseconds of latency. Didn't do great things for the video quality. So it was really revolutionary, the idea of putting out, and it predates video, which is what Pankaj is thinking about. To be able for each individual sender to be able to encode in multiple resolutions. And then some router at the front end would say, you are getting QSIF or some low resolution, but you're HD. And just being able to do that without transcoding, the latencies go down. These boxes can handle 1,500 participants and cost $1,000 back in 2008. I mean, it really changed, and that's really how it's done today in video conferencing. Go ahead.
Even in video conferencing, so scalability is used, you're saying?
Well, it could be not. It could be SVC,
yes,
but it could be simulcast. What we use is KSVC, which is it's strictly an SVC, but we only use SVC on the keyframes because you get a huge gain on the keyframes.
Okay, so you do SVC just on the keyframes, and then how much every half second or second?
No, we don't have intermittent, but when the keyframe comes.
I see.
It's to error when somebody joins or when there's an error. Yes.
Okay, can you do just simulcast on keyframes?
You could do that. You could, but
It's called S frames.
it's called
S frames.
Yeah.
Road and
Oh.
Nika Farber, 1976. 1996.
So there is a use. In fact, so what Michael's telling us is that multi-party conferencing, where the multiple parties have naturally going to have different bandwidths available, at least instantaneously, is a natural place where scalability can play a role.
And it's also device capabilities, just some people.
Yeah, and device capabilities.
Yeah.
So in fact, scalability will have a future in this right now. I have another 10 or 15 questions that'll take us another 3 hours, but I want to be able to open up the discussion to the audience that we have over here. I wanted to get to, the use of video quality. For example, we've done, 35 years of compression research and development, 35, 40 years. And we've increased video quality compression efficiency by 50x. In 35 years, we've increased compression efficiency 50x from 261 to 266. It's a 50x gain. That is monstrous. Nobody predicted we could do that much more compression. One question I wanted to ask was, how much more is there left? Can we squeeze some more blood out of this, or have we come to the end of the line? ECM, it's getting us 15% more. AB2, they're suggesting maybe 15% more. But are we going to get another factor or two? You have any idea on that, Fabian? Let's just go really quickly, and I'm going to open it up to the crowd. Let's go.
So
Real quick.
yeah, there's ECM and all that tests with some intra prediction and AI-based filters.
Yes.
We can go to 23%.
23% over VBC.
There's still room.
And there's still room. So you see another half coming. You think that's quite possible at least. Okay, good guess, good guess. Okay, now what do you see here?
Oh, it really depends what we are compressing.
Content dependent, yeah, of course.
And how much noise is there. And if I just look at rate distortion shapes of what's achievable with codec today, with realistic codecs, they are operational rate distortion, PSNR rate. They don't behave in a way how classical information sources should. It's not a Gaussian source rate distortion where you have like 1 bit equals 6 dB. We are not growing in the right at the right shape of that.
So theoretical things can't help us get us an answer.
Well, you always have to stand here if you want to achieve something serious. But in this case, we're just doing something that doesn't behave the way it should if you would be doing it right.
But what conclusion do you draw out of that?
That there must be some potential.
Oh, so you see more potential, okay. I couldn't understand that from what you're discussing. What do you see coming, Simon? Do you see another half coming?
Oh, it's tricky. So I make two observations actually. So the first one is that you
Quick,
say
I want to
50.
reserve another few minutes.
Yeah, very quickly. So you say 50-50x, but yet I believe even yesterday we were discussing that still people use probably, and you said at the beginning of the conference of the panel that we still use codec that were 20 years.
Oh, yeah.
So it's true that we can do a lot, but maybe the blocker is not necessarily the compression. So my question, which is my second observation, I already mentioned earlier, but are we sure that when we talk about compression, mathematically, I agree. Mathematically, that's what compression is if you take a mathematical approach, but are we defining the right problem when we look at compression just by reducing the bit, or do we need to start putting other things in it? Is a video codec just for compressing video, or is for more than that?
Well, there are many other things we
I
go
know there is a philosophical question, but since I didn't have much time
We will
to
never get
answer,
into that.
I will
Matthias,
not
quick,
get
you see another...
Just as a comment, I think the last one was called versatile video coding. I think that was the idea behind, so it was more than just compression. My thinking is, so if you look at the generations of codecs,
Yeah.
this factor of two thinking always came actually with a application change or a resolution change. And that's where you got the 50%, right?
Right.
And ABC was developed using QSIP and SIF, and then later on there was some SD coming, and then it was recognized that maybe this baseline profile was not the whole world because it was only the small transforms. I was very fond of having larger signals.
So if we go to 16K, then maybe we'll get another
Well,
half.
switch the application, switch the signal characteristics, and then you can get 50%, I'm pretty sure.
Okay.
But if you are in the typical range, then it may be a bit tough.
But my 4K TV, when I'm sitting in my living room, my couch, about 10 feet away from the TV, and with the vision that I have, I'm not going to see 8K.
No.
I'm certainly not going to see 16K, and I'm certainly not going to spend that money when I can't see the difference.
But I think if you talk about immersive video, if you have an
okay.
application for that, then you need these resolutions, then it works.
Well, back to immersion.
I guess that you're not using the 4K display and the UHD video in the way that it kind of would be designed for, with this 1.5 viewing distance and stuff like that. People are using it very differently, and the consumer, it's hard to be convinced to basically refurbish the whole home to be
I'm not going to change my living room,
to
so
view the stuff
the
the right
TV's
way.
going to stay where it is, and I'm going to stay
Yeah,
where I
sure.
am.
Exactly.
That isn't changing.
Exactly. And then you don't need ultra resolution.
Yeah, so you don't need it, okay. So there it is, a commercial limit. There may not be a theoretical limit, there's going to be a commercial limit. Go ahead, Michael.
I'm going to defer because I want to have time to answer questions.
Oh, okay, yeah. So let's, even though we're going to go over a few minutes, let's get some questions and queries from the group. And don't be shy, come right.
The view.
Yeah.
Yeah, your comments about real-time comms and the importance of real-time comms, I think this pandemic really brought that home in the last couple of years. And I think of all the application areas, there's a lot of space to go there. Do you see a role for, so now we codecs are like a massive handcrafted picture predictor, right? And do you see a role for the recent, deepfake generators in trying to push those bits even lower for specific applications?
That's a good question.
In other words, just fake it, right?
Well, not fake
Yeah.
Well, even if you just have the predicted picture,
Right.
right?
Right.
It may be a better.
Yeah. So in fact, all the AI-based tools are really, generating a fake video.
So I'm thinking in smaller, in baby steps. You're thinking almost certainly yes is the short answer. What I'm looking at For me, the single biggest advance for AV1, say, over earlier generations, and HEVC had this also with the sample adaptive offset, but it's this constrained enhanced directional filter. This nonlinear filter in loop that at very low bit rates. Now, people who look at like the gamers at 40 megabits per second for HD or 1080p, I don't know how useful it is in that space, but at 15 kilobits per second, it's a lifesaver. All these rings of the block artifact, they just melt and become, they don't go away, but they're just graceful degradation. It's much more interesting. I see maybe as an early step better in-loop filtering that will help us at the very, very low end.
Awesome.
This is Ryan Lee from Meta. I see recently a lot of AI or machine learning based tools kind of introduced in the standard development. So do you see like fundamentally that's going to change the new technology or how this is going to be developed in the future? Yeah, that's my question.
AI or?
AI and machine learning.
Oh, yeah, so in fact, that was a line of questioning I didn't get to even, but, machine learning is playing an increasing role in how much, how far is that going to penetrate? Are we going to get to a point where it's going to be an end-to-end machine, AI-based codec? Are we getting there? So real quick,
That's my
yes,
hope.
no.
That's my hope, yeah.
That's your hope, so you're hoping,
I work on that.
you're putting your mortgage down on that. Okay, go ahead.
Maybe for machines first.
Yeah, okay, so there's also video coding for machines. And in that space, because the application is then exploitation anyway, then, it makes sense to build an AI-based codec. Yuri, go ahead. You don't like it. Yuri's are...
I love it. The question really comes down is that, of course, at some point you could use neural networks to synthesize Fourier transform on DCT. If you train it, that's exactly what it will learn with proper training set, right? The question is whether running that cascade instead of DCT or Fourier will be practical and will give you any tangible benefits considering complexity, practicality, efficiency of the ultimate solutions that you're trying to get.
So right now, all the solutions that use AI for coding are like 100 times more complex or more. Right? They're not anything realistic, but GPUs will change. Fabian, you had a comment.
You can put your accuracy
But by the way,
directly with us.
if I connect back to mathematics, it's known since 60s, since Kolmogorov and Arnold, that you need just 2 layers to synthesize any n-dimensional functions. You don't need, just at least at theoretical level, there is some disconnect.
So what he's pointing out is that you don't need a deep neural network. 2 layers is enough to approximate any function. So that's really impressive stuff. So go ahead. Any other comments on?
I think it's in particular for certain application. Definitely, I'm even probably for communication where, to a certain extent, the landscape doesn't change that often. And you can predict. It's a very predictable kind of type of content. You can probably use easily even nowadays train AI, particularly on the encoder side. I think the key question is on the decoder side, because the number that I see is, 10x, 100x of what is already 10x, of previous generation codecs. So obviously we are very far from it, but I'm sure that some AI tool will
all the work being done,
using
say,
them
neural
as well,
network-based
so.
research, at the standards committees, those are very, very high complexity right now that I'm seeing. Yeah, so we'll see, but things change. Go ahead, Matthias.
Maybe a quick one. In VDC, we have a tool which was actually derived from neural networks.
Yeah, a faster way to do interprediction.
Yeah, so that's exactly that's matrix-based interprediction, and it's so it started as a neural network, and it was tweaked by the demands of the standardization group and the complexity considerations, and at the end, it was a matrix multiplier. But I think the interesting point is, so you have the network sparking an idea, and then it's made applicable.
So it's already impacted a standard right now.
Yeah, but I think so. It was an inspiration, and then it was made practical. And I think that's probably something which is very, very important. And I think like the loop filters are this field where we see the biggest gains right now for the networks. Maybe we find a way to make it low complex, and then it could also go into a regular codec. Just on the other things, if you think about those very, very low bitrate applications, if you think back in the 90s, late 90s, there were those head-shoulder sequences when people would just put a model and then they would just send some animation for it. And if you
Avatars.
same could, yeah, well, it's not avatars. You just send a picture and then you animate it, and you don't. And then it's super low bit rate for that specific application. And a network that is trained obviously could do the same. It's just a matter of how you design it. I think it's kind of solving the same thing, right? So you have a reduced set of options. So you don't want to have this camera that captures everything, but you want to have this communication scenario, and there you could get it massively. And I think also maybe it's.
Okay.
And so I want to talk about the uncanny valley, and I assume that most of you understand that there's this idea that if something is not very like real life, you're comfortable with it, and then as you get to exactly in real life, you're comfortable with it. But right before you get to where things look really realistic, there's this uncanny valley where it's creepy. If you saw Polar Express, the eyes weren't quite right, and it really creeped a lot of people out. That's just an example of it. These ideas
So those video games where it's not realistic, you know, it looks, people are fine with it.
It's okay if it's not realistic. It's okay if it's perfectly realistic. It's not okay if it's almost perfectly realistic.
Wow.
That's really disturbing. And so if those models are 100% on, I'm in. But when you're talking to someone and then their nose goes over here, it's very distressing.
Or
Yeah.
like the mouse is wrong and the impression is wrong.
Yeah, or the expression is just wrong. What are you smirking at?
Yeah.
I'm not smirking.
Yeah, interesting. Well, listen, we're going to have to end our discussion here, but I want to thank our panelists for their time and effort and the excellent comments that they made. Thank you very much. I've enjoyed this discussion. And thanks to this audience for listening and for participating with us. It's been our pleasure, and another time maybe we'll do another one of these. Thank you so much. Take care.